So in 3.5 we learn what all the derivatives are for all of the trig functions. So it turns out that the derivative of sine is cosine. So I'm going to show you where that comes from. So it's certainly true that the derivative of sine is cosine, but I'm going to create this and show you why it's cosine. Okay, so when we take a derivative, the way we do it is we take the limit as h goes to 0 of f of x plus h minus f of x all over h. This is how you find a derivative when you don't have a shortcut. And for sine of x, well, we know the shortcut now. It's cosine, but just to show that, to verify that it is cosine, we're going to go back to the old way to figure it out. Okay, so that's the limit as h goes to 0. So this would be minus sine of x over here, because the function that we're taking the derivative of is sine of x. So f of x is sine of x. And then f of x plus h, that means plug x plus h into this function. So if you plug 7 into this function, it would be the sine of 7. So if you plug x plus h into this function, it would be the sine of x plus h. So there is the derivative for sine started out. Okay, now at this point, it's really tempting to distribute the sine and write it as sine of x plus sine of h, but that's just not true. Sine doesn't distribute past plus. So if you typed in sine of 30 plus 20, and then tried sine of 30 plus sine of 20, you'd get two different numbers. So it's not legal to distribute sine across plus. What is true is an identity that you learned, or at least saw last year. And I don't totally have it memorized either, so I certainly don't expect you to have it memorized. It's the sine of x times the cosine of h plus the cosine of x times the sine of h. So all of this whole big nasty thing here, is equal to the sine of x plus h. So there was just an identity last year that said that that was the same as this. So I'm just using that. So then after that we have minus sine of x over h. Okay, now next I'm going to swap these two things up here. So that's the limit as h goes to 0 of sine of x cosine of h minus sine of x plus cosine of x sine of h all over h. So that wasn't a tough step. All I did was rearrange and swap that term with this term. Put the minus sine of x first and the plus cosine sine second. All right, the reason I did that is because now I can factor a sine out of that. So that's the limit as h goes to 0 of the sine of x times the cosine of h minus 1 plus the cosine of x times the sine of h all over h. So it's not a real big deal. All I did was notice that both of these had a sign, and so I pulled the sign in front, factoring it out. Okay, now next I'm going to distribute the h past this plus. So split this up into two separate fractions. So that's the sine of x times the cosine of h minus 1 over h. and then plus the cosine of x sine of h over h. And of course, eventually we're going to take the limit as h goes to 0 of that. So this has happened a few times this year, so it's becoming less unobvious. But a lot of times when you have a common denominator, then you go ahead and add them to this step. But it's unusual to go from this step to this step. Take one fraction and split it up into two, but it's really the same thing. If you have a common denominator, you're allowed to add. Okay, now this sine of x, I want to pull off to the side. So that's going to be the sine of x times cosine of h minus 1 over h. So I'm taking that fraction and splitting it into two things. And what I'm doing there is I'm thinking of sine of x as sine of x over 1. So if that was over 1, then you would just multiply across the tops and get that. And then if you took 1 times h, you would get h. And then I'm going to do the same thing with the cosine over here. Okay, so now I'm going to do a bunch of limit laws. I'm going to move the limit past the plus and also past the time signs. So there's going to be a limit in front of here, and a limit in front of there, and a limit in front of there, and a limit in front of there. That's just two limit laws. Limit can go past plus, and limit can go past multiplication. Okay, so that's the limit as h goes to 0 of sine of x times the limit as h goes to 0 of cosine of h minus 1 all over h plus the limit as h goes to 0 of cosine of x times the limit as h goes to 0 of sine of h over h. So a bunch of limits using two different limit laws. Limit can go past plus, and limit can also go past multiplication. Okay, so here is the most recognizable limit. Limit as h goes to 0 of sine of h over h. That h's might be throwing you off. If that was an x going to 0 of sine of x over x, you would probably recognize it quicker. But what is that limit? It comes out to 1. So we've already said that that's a fact, that this limit comes out to 1. So that's nice. We just got times 1 down there. So sort of, that's what all this algebra was about. Getting that limit isolated. That limit turns out to be 1. Okay, now this limit here, h is going to 0. And as far as h is concerned, x is a constant. So when h changes, x stays the same. So when you take the limit as h goes to 0 of cosine of x, it's just like taking a limit of a constant. So that's just going to come out to cosine of x. Same thing here, right? When h goes to 0, x doesn't change, so this limit is sine of x. Okay, so really the only thing we have to work on is this limit here. And this is another famous limit, but this is the first time you've seen it. This one is famous, and I showed it to you before. It comes out to 1. This one comes out to 0. And if we hadn't had team this morning, I would have done a table on this limit. But I just want you to take my word for it that that comes out to 0. But we could quickly, easily make a table. Just pick some numbers close to 0, plug them into this, and the outputs would get close to 0. Okay, so that's good, because then the sine of x times 0 is 0. and the cosine of x times 1 is cosine of x. And so we are getting the final answer, cosine of x. So I wasn't lying back here when I said that the derivative of sine was cosine. Okay, so there's 5 other trig functions, and so we're going to write down the derivatives of those as well. But I'm not going to prove those like I did sine. I'm just going to ask you to believe me on that. Okay, so the derivative of sine, we've already written this one down, is cosine. The derivative of cosine is negative sine. So this is going to be difficult for you to remember which one is negative. So just watch out for that. Then the derivative of tangent is secant squared. Then the derivative of cosecant is negative cosecant times cotangent. And the derivative of secant is secant times tangent. And then finally the derivative of cotangent is negative cosecant squared. Okay, so to help with your memorizing, notice that this is cosine and cosecant and cotangent. And all of those have opposite signs in them. They're all negative. So that'll help. Whenever you have the derivative of a co, it's going to be negative. Well, it doesn't have to turn out to be negative, but it's got the negative sign in the derivative. It could be the opposite of a negative number. It could turn out to be positive, but the negative sign is in the derivative. So this one's got an opposite sign, that one's got an opposite sign, and so does that one, and they're all co's. All right, so now we're going to work with those facts and do a few problems with those. So the first one is y equals cosine of x all over 1 plus sine of x. And we're going to find the derivative. Okay, so when we figure out this derivative, what rule do we have to use? Quotient rule, good. So since there's division in this formula, while we take the derivative, we have to use quotient rule. So today we're learning the new trig derivative, but we still have to apply our old rules. Okay, so the way the quotient rule works is you take the derivative of the top, so the derivative of cosine, which is negative sine, so there's the derivative of the top. And I'm just taking this fact here and using it. So derivative of the top times the regular bottom minus derivative of the bottom. And when you do the derivative of the bottom, the derivative of 1 is 0, and the derivative of sine is cosine. So the derivative of the bottom is 0 plus cosine, which is just cosine. So there's the derivative of the bottom. So derivative of the top times the regular bottom minus derivative of the bottom. Then you have to times by the regular top. So there's the regular top. And then you put that all over the bottom square. So don't forget that if this is a free response question, you can stop here. Now, usually there's some simplifying that goes on if it's a multiple choice question. So I'm going to practice that so that you get some practice with it. But if it's a free response question, stop here. The calculus is finished here. Okay, but just practicing a little bit. I want to take this sign and distribute it. So negative sine of x times 1 is negative sine of x. And then negative sine of x times sine of x is sine squared. And then cosine of x times cosine of x is cosine of x squared. Okay, so I just multiplied the sine through and got sine squared and sine, and multiplied the cosine by cosine and got cosine squared. Okay, now since everything on top is negative, I'm going to factor out the negative 1. So this is negative 1 times sine of x plus sine squared plus cosine squared. So from that step to that step, I just got the negative out of the way there. Okay, then what is sine squared plus cosine squared? Good, it equals 1. So that was another identity from last year. Sine squared plus cosine squared is 1. So instead of writing that, I can write 1. So that's y prime equals negative 1 times sine of x plus 1 all over 1 plus sine of x squared. So all I did was replace this and put a 1 instead, but that's okay because it equals 1. Okay, and then you can see that somebody doctored this problem nicely because the 1 plus sine of x on top is going to cancel with a 1 plus sine of x on the bottom. So the final answer is negative 1 over 1 plus sine of x. So on this problem, the simplifying was productive. This certainly would be easier to work with than this. But again, on a free response question, it's okay to leave it like this. Okay. Here's example 2. So we're going to have y equals the secant of x. And the question is, find an equation for the tangent line. And the normal line. At x equals pi over 4. Okay, so we're finding an equation for the tangent line and the normal line at x equals pi over 4. Okay, so if we're going to write an equation for a tangent line, what is our final product going to look like? Y equals mx plus b, right? Equation of a line. So this is what we're shooting for. But before we can write the equation of a line, we need to know the slope of the line. And this line is the tangent line, so we're looking for the slope of the tangent line. So in order to find the tangent line, of course, we take the derivative. That'll give us the slope of the tangent line. Okay, so taking the derivative of this is just apparently secant times tangent from the fact that we wrote down just a minute ago. So the derivative is secant times tangent. So this is a formula that'll output the slope of this curve at any point. So in particular, I care about the slope of this curve at pi over 4. So I need to plug pi over 4 into this. Okay, so I need to take y prime and plug pi over 4 into it. So that's going to be the secant of pi over 4 times the tangent of pi over 4. Okay, so if this is calculator active, it's totally fine to type this into your calculator, and then you would round it to 3 decimal places. But it's possible that this will not be calculator active. So in order to figure out the secant of pi over 4 and the tangent of pi over 4 without a calculator, we've got to think about the unit circle. Okay, so here's the unit circle. And I know that a lot of the time you were allowed to use your unit circle on tests last year. You're not allowed to on the AP test. So you just kind of have to construct it. Okay, so for pi over 4, that's right here. It's a 45-degree angle. And the terminal point is root 2 over 2, comma, root 2 over 2. So at some point you just need to have memorized that pi over 4 is that. It's easy to remember that they should be the same because on a 45-degree angle, this x is the same as that y, right? Okay, so that's the terminal point for pi over 4. So now we've got to figure out the tangent of pi over 4. Tangent is the y value over the x value. So it's this divided by that. So of course that's going to come out to 1. So tangent of pi over 4 is 1. So I had to know that pi over 4 was this, and then I also had to know that tangent was this divided by that to figure that out. Okay, then the secant is 1 divided by the cosine. The cosine is the x value on the unit circle. So it's this. Now, on this problem, it's a coincidence that the y value is also that. But if we're figuring out the cosine, we're looking at this number, the x value, because the cosine is the x. But we don't want the cosine, we want the secant. And the secant is the reciprocal of this, 1 divided by this. So that's 2 divided by root 2. So secant of pi over 4 is 2 over root 2. And then, of course, if you take 2 over root 2 times 1, that's 2 over root 2. Okay, now in the past, they said that every time you had a square root in the denominator, you had to rationalize it. If it's a free response question, you don't have to rationalize. So I'm not going to. But sometimes on a multiple choice question, they will rationalize. So I'm not letting you off the hook. I'm not saying you never have to rationalize. You might have to someday. But I'm also saying that you don't have to do it every time. It's not some law. I mean, they said it was a law in the past because they needed you to practice. But now that we're getting more sophisticated, you don't have to do it every time. Okay, so I'm going to leave my slope like this with the square root in the denominator. I know it makes some of you feel uncomfortable because you were told you can't do it. It's okay. It's going to be all right. All right, so there's my slope. Okay, so now I'm going to come back here and put that in for my slope. So I'm on my way towards writing the equation of the line. I've got my slope. Now all I need to figure out is my y-intercept. Okay, so to figure out the y-intercept, I need a point that's on the line, or on the curve. So I have my x value for my point already. That's pi over 4. So I need to figure out the y value at pi over 4. In order to figure that out, I just plug into the original formula. If I want the slope, I plug into the derivative. If I want the y value, I plug into the original. So I just got to take the secant of pi over 4. We already figured that out. It was right here. It was 2 over root 2. Now it's a total coincidence that this y value is the same as this slope, right? It's just because the tangent was 1, and so this was multiplying together to be the same as the y value. But that usually won't happen. So I found this by plugging into here, and I found this by plugging into the derivative. Two different formulas. Okay, so now I'm going to use that point to figure out the y-intercept of this line. So I know that if I plug pi over 4 in for x, so I'm just putting pi over 4 in there for x, I know that I want this to spit out the y value 2 over root 2. So knowing that, I can work and figure out what the b is. So I'm going to multiply across here, and that's 2 pi times 4 root 2. So this is looking really nasty, but don't stress out about it. It's just 2 times pi, which is 2 pi, and 4 times root 2, which is 4 root 2. So really I haven't done anything. I just put them together. And then to figure out b, I can just subtract that to the other side. So b is 2 root 2 minus that mess. And if I wanted to, I could get a common denominator and combine those fractions. But I don't need to. This is b. Okay, so the final answer for the tangent line is y equals 2 over root 2x plus this whole mess, which is b. 2 over root 2 minus 2 pi over 4 root 2. So again, maybe if it's a multiple choice question, maybe they get a common denominator, and then maybe they rationalize both of those. So someday practice that, but it's not necessary. For your response question, this looks really nasty, but it's just fine to leave it. And in fact, if you go further and make a mistake, even if this is right, you get less points than the person that leaves it. Okay, so we still have to write the equation of the normal line, right? Because this question asks for two different lines. It asks for the tangent line and the normal line. Okay, so for the normal line, still got y equals mx plus b. So the slope of the tangent line was 2 over root 2, right? So what's the slope of the normal line? You do the opposite reciprocal, right? So instead of 2 over root 2, it's going to be root 2 over 2 and then negative. So y equals negative 2 over root 2x plus b. No, I messed up. Root 2 over 2, sorry. Forgot to flip it. So that's nice. To those of you who are cringing with the radical in the denominator, now there's not one, so this is going to make you happy. Okay, then for the normal line, remember, we have our graph of secant we have our tangent line, right? The normal line goes through the same exact point as the tangent line. They both go through pi over 4 comma 2 over root 2. So I'm trying to emphasize that the normal line is also going through this point, the same point that the tangent line went through. That's what a normal line is. It goes through the same point, it just is perpendicular to the tangent line. Okay, so that means I can use this point to figure out my b for the normal line as well. So that's, if I plug in pi over 4, it is supposed to spit out 2 over root 2. Okay, so then multiplying across, that's negative pi root 2 over 8 plus b equals 2 over root 2. And so then b is adding that to the other side. 2 over root 2 plus pi root 2 over 8. So y equals negative root 2 over 2 times x plus that nasty mess. 2 over root 2 plus pi root 2 over 8. Okay, so my advice to you for the rest of the year is whenever the unit circle pops up on homework, try not to peek at your unit circle. Attempt to do it without looking. Because if you don't do that, your brain isn't going to ever know what it is. So just try, and I just draw a little picture and just worry about the point that I care about. I don't try to draw the whole unit circle. Like on this one, I only cared about pi over 4, so I just drew that one. And it'll pop up enough, you know, here and there, that hopefully eventually you'll have it. And if you need help with that, because I know that's tough, don't hesitate to ask me. I can help you with that. All right, so we got one more. And this is kind of a preview of what's coming up later. So we've got the sine of 2t, and we're trying to find the derivative. Sorry, this should be dy dt, because the variable is t. Okay, so this is a different kind of a function. It's a composition. So why is this function a composition? Yeah. Because it's a function plugged into another function. So the function that's inside is 2t. And then it's the sine of that. Okay, so this is not multiplication, right? There's not a sine times 2t there. If it was sine of t times 2t, that would be multiplication. But this is different. This is 2t plugged into sine. So that's why it's a composition. It's a function inside of another function. Okay, and we have not learned yet how to take the derivative of a composition. That's the topic for next week. So if we do it, if I'm asking for this, We don't totally know how to do it yet, unless we come up with some other method. Okay, but I want you to start recognizing compositions. So the main point of this problem is for you to realize that this is 2t sitting inside of sine. Inside function's 2t, outside function is sine. And so it is a composition. So we can't just do the derivative straight up. Okay, now in order to do this problem, we're going to use an identity so we can get around knowing what you're going to know in the future. Okay, so the sine of 2t is 2 times the sine of t times the cosine of t. So this is just a rewriting of the original y. So there's an identity that says that sine of 2t is the same as 2 sine cosine. Okay, so now in this form, it is two things multiplied together. 2 times the sine of t times the cosine of t. So we do know how to take the derivative of that. Yes. So I haven't done a derivative yet. No, you're good. That's a great, because usually we're doing calculus. So this is still the original y. It's just I used an identity to rewrite that in a different way. But this is equal to that. So I haven't done a derivative yet. But I'm about to do a derivative. And the way I'm going to do it is it's a product rule because we have this times this. Okay, so when we do the derivative of this mess, we can use product rule. So we didn't know how to take the derivative of a composition yet. That's for next week. So I decided to rewrite it, and now we're going to use product rule. Yes? From the list of identities, there were 50 of them on a paper, and that's one of them. Yeah, and it just seems like it comes out of thin air, and it always bothers people. So you just, I mean, actually, do you have your calculator? This will help solidify it for you. So I'm not going to have time to finish this derivative. That's okay. The main thing I wanted you to get out of this is that this is a composition. So type in sine of parentheses 2 times 15. And then you get a big nasty decimal. Okay, now press 2 times the sine of 15 times the cosine of 15. Same decimal. So whatever number you pick, I just picked 15 randomly. You can play around with that all day. No matter what number you pick, you're going to get the same number for that and that. So this is the same as that. And I know that from the list because I've been doing it for years, but I don't expect that you know that. Just that you say, okay, yeah, that's one of those things that I don't know, but at least I'm aware of it. All right, cool. Thanks. Thank you for listening. Great question, Connor and Brandon. That really helps.